All right, let's talk about distance, position, and displacement. And I've informally talked about what distance, position, and displacement are, but let's be formal about it, okay? Here's position. Well, let's get some things about what position is. It is always relative to an origin, some 0 point. It is always related to a direction, a frame of reference, a direction. A directional frame of reference, I should say. Gentleman at the back. It always has magnitude units. Sorry, it always has magnitudes and units. Always has magnitude and units. And in most of our calculations, the units are going to be in meters. But frequently kilometers will creep in, centimeters. But we're always going to try and get it into meters. So for example, we could say the ball landed 14.0 meters east, capital E in brackets, east of the tree. And that's the ball's current position relative to the tree. E is for east. Displacement. Really, at the end of the day, it's how far you are from another position, how far one position is from another position. And in what direction you'd have to point yourself in to go to another position. So it has a direction. Associated with a vector connecting the two positions. So if I have position 1 and position 2, now those two positions might be relative to position 0, but position 1 and position 2 would be connected by a vector going from position 1 to position 2. I might call this the displacement, and that displacement is going to have an angle associated with it relative to a reference frame. So that's the direction. And we might measure the direction relative to east. We might measure that direction relative to horizontal, but it has some direction associated with it. Or it might be 2 points like this one here. 2 points that are maybe one being east of the other point, where this is point 1 and this is point 2. And I could have a vector like this, where there's no angle really. But the delta D, if the reference frame was north, south, east, and west, where north might be positive, east might be positive, south negative, and west negative, this displacement here, let's call this displacement A and this displacement B. Displacement B might be 7.63 meters east. Okay. Whereas if we ended up getting that angle there to be 40 degrees, we might say that displacement A is, I don't know, 9.25 meters, and this is how we'd say that you would express the direction, by the way, if there's an angle. And we'll have more practice with this, but I just want to bring it up. East, 40 degrees north. What we mean is, if you point yourself towards the east and then rotate yourself by 40 degrees towards the north, that'll tell you the direction in which this arrow is pointing. Another way to express it, and different people use this one as well, but it's just as valid. Our textbook happens to use this one right here, but I'll show you another one because sometimes if you're on the internet, you'll see this other way of expressing these directions. 40 degrees to the north of east. Either of those are valid. So this is 40 degrees to the north of east. So if I start off pointing myself to the east, I'm going to rotate myself 40 degrees towards the north. And that'll tell me the direction in which that displacement vector would be pointing it. They're equivalent ways of expressing the same idea. All right, I'm going to pause that.